Ioannis.
Hi Peter, good to see you.
It's always a pleasure to be here.
It's been a while.
Yes, you've been working on phospholamban R14 deletion for quite a few years.
Correct,
now.
yes. I started way back in 2013 actually, when I was a postdoc at the Roger Jazz Lab. And we started, the project we started there was the patient-specific iPSCs. So
yes.
we approached some of the families at the time from Greece,
yes.
and we obtained some blood cells from one of the patients, and we started reprogramming. And the idea was to use a different model. So up to that time, most of the work was done in mice.
Yeah.
And what we wanted to do is to introduce a new concept and use patient-specific cells, like take blood from a patient, and using a cocktail of factors, we can make heart cells, so convert blood to heart. And that comes from the patient with the disease, with the mutation. So we can actually use that model to understand the disease a bit better. And that was the focus of my work.
Yeah, and in that way you save a lot of animal testing.
Correct.
Because you can do it on
and also
patient material,
absolutely.
Which is a very good model.
It is more relevant to the human disease. And then we think there's animals are still useful for many things, but what we're trying to do here is to introduce a different aspect of the research and try to understand the mechanism from a human kind of perspective. And also from the patient, so each patient is different. So we have a collection now of cell lines derived from different patients, including yourself, and from the Dutch families. And we also have a number of patients that came through the Stanford hospital. It was surprising. We have at least 3 families, 3 patients from 3 different families that are, accidentally came to the clinic and were diagnosed with the same disease. So I think it's more widespread than we originally thought. We started as a small project with a family in Greece, and now we know there's hundreds and hundreds of, maybe thousands of patients that might be benefited from the research that we're doing.
Yes,
that's pretty exciting, I think.
And then you came to the Mark Mercola lab here in Stanford. And
correct. I came here, originally to Joe Wu lab, was on the CVI, the Cardiovascular Institute, as a kind of assistant professor. So I continue the work I started as a trainee, and I have my own team, and we're actually still working on some of the findings we had using that model, like the human patient model.
Yeah, and then you also came up with the idea that the unfolded protein response might play a factor.
Correct. We had one of the original studies we'd done when I moved here was to take some of the patient cells and using some new technologies to understand the disease. So we use this single cell RNA sequencing, meaning they take one cell and you compare it to a control cell. So based on this initial work, we discovered that there was some signature of a signaling pathway that's called the unfolded protein response that might be implicating the disease. In some way, we talked about it many times actually, but we are making a lot of progress, and we have some new directions that we are using some test compounds to probe to understand a bit of this pathway and what the role in the disease. So it's still in early stages, but we see some exciting data, and we are hopeful that hopefully in the next few months we should have some more concrete data that maybe this is a good pathway to target for the disease. It's complicated, but we have putting a lot of effort, and hopefully, as I said, in the next year we should have some more interesting data coming from this original work on the unfolded protein response and signaling.
You're also, and Dries is helping you.
Absolutely, yeah. Dries has been instrumental actually on moving these things forward. So when I came here, we started making lines actually from your family. We have used also the genome editing tools. We have the proper controls. We have made a lot of progress on making the cells into cardiomyocytes. We have enough now to use for high throughput screening. So that's what Dries is focusing. I think he talked a bit about it. We'll talk about it this morning, but I think the direction is that we making a lot of effort to use some of the findings in my original findings and moving it towards more like a clinical translation. It might take time, but we're in the right direction, I believe. So we're pretty excited about this.
And now, parallel to this, you're also working on microRNAs to see whether they can influence the disease.
Correct. We have done we talked about it this morning. So there are some new tools and some new it's called like the interference RNAs that we're working on, and we have found a few actually we're testing a number of microRNA based kind of technologies to silence, to make sure that we can specifically target the mutant protein, the mutant phospholipid, and leave the wild type, the normal copy alone. So we'll try to find some therapeutics based on this new silencing interference RNA. So we have some progress, and we talked about more specifics more, but it's pretty exciting actually. I mean, we didn't expect to have such a big influence. So
I was
it was pretty
very
impressive. Yeah.
Yeah, I was impressed
I was like,
this morning.
yeah, that's pretty good. I think we are in the right direction. I think, and probably, hopefully, as we discussed, and I think in the next, maybe year, if we can find a partnership, somebody to move it towards the clinical translation. I think that probably is a lot of promise there.
Because it will take years before
Correct.
we can bring it to
Absolutely.
patients.
But we do
find the
correct.
real interesting
And we have
pathways.
tested it actually. All these tools that we developed, we're testing in actual human patients. I mean, one of the lines actually has been the workhorse here, so we use you as a test. So you are the guinea pig, so to speak. But
Happy to.
yeah, I think we talked about it. These things take time, but we are making effort, and we have I have 2 postdocs working on it. Dries is also, and Mark's group is investing some time and effort.
Yep.
So we're making a lot of progress, and I think we keep up the pace. I think we make some significant discoveries. I think in the next few years.
Yeah.
I think that's the.
And I'll be back with you. In
Yes, I
about
know.
6
You're
months.
6 months. You're gonna tell us we're not doing fast enough.
Well, we're trying to help you wherever we
Yeah,
can.
absolutely. No, I think
Yes.
you've been very helpful, and I think also inspirational. And just access to the patients, access to the clinical data we have with collaboration with the Dutch groups, with the Leduc, I think helped a lot. I think we're meeting next week,
Yes.
and we're looking forward to sharing knowledge and expertise. And we all work together, I think, and everybody brings something to the table. And I think that's the exciting part of this particular project. It's not just me and us here, but
It's a whole team, worldwide
the whole
team.
absolutely. And I think the Leduc grant also helped a lot. The Leduc Foundation has helped us, and we put together a great team, I think, and we're making some progress. And we meet every 6 months to discuss and exchange ideas, and hopefully, as that is, there's a lot of things going on. And I think when I started, I was just myself basically. When I was with my mentor at the time, Roger, and we said, what we can do is just it's a good model, and let's try it we didn't choose phospholamban because we knew about it. It's just choose because that was available at the time, with Liza Kranias from Cincinnati and her original work in the Greek family, and that started more or less everything. So I think that's pretty exciting to see something coming from an idea and something to test to become like such a big project,
Right.
and hopefully, as I said, you might have an impact in people's life, and I think that's what we're here for.
That's what we're aiming for.
Yes, correct. And I think we should be there.
Okay, thank you
We'll
very
be
much,
there.
Ioannis, and wishing
Thanks.
you all the luck
Thank
you need.
Thanks for coming. It's great to see you.